Okay, I'm going to finish up 6.5 real quick with dividing with complex numbers and taking complex numbers to some power using an exponent. Now when dividing, if you had maybe, let's say 2 minus 3i over 3 plus 4i, you could always multiply by the conjugate and all of that. That's fine, but I want to show you how to do it when they're in trig form, which is going to be way faster. And sometimes I will ask for you to, even if I give you the problem in standard form, to put it in trig form to do the multiplication. So, the first thing we need to do when we're dividing with our complex numbers in trig form is we are going to divide the r's. So z1 over z2. For my r's, I'm going to do 24 over 8. And I'm going to subtract the thetas. So times cosine, and then I'm going to subtract these. So 300 minus 75 degrees plus I times sine, and again it's 300 minus 75 degrees. 24 divided by 8 would be 3. 300 minus 75 is 225 degrees. So I have 3 times cosine 225 plus I sine of 225. This is my answer in trig form. Now a lot of the time I'll ask for the answer in standard form. So to do that, remember you just actually do the trig. So do the sine and cosine. If it's on your unit circle, which this one is, you should use those numbers. If it's not on your unit circle, then you are going to want to use your calculator. Since this one is down in quadrant 3, cosine of 225 is negative radical 2 over 2. Sine of 225 is also going to be negative, so whether you make it plus a negative radical 2 over 2i, or if you just did minus there, is up to you. And then finally just distributing that. So I get negative 3 radical 2 over 2 minus 3 radical 2 over 2i. This is my answer in standard form. Last thing we're going to look at is actually doing powers. Now you have to be in trig form to do this. So must be in trig form. The only exception, I guess you could say, it's not really exception, but if I was going to do like 2 minus 3i squared, then I could go ahead and just list that out twice and multiply it. But anything else, if I was going to do it to the fifth, I'd have to do 2 minus 3i times 2 minus 3i times 2 minus 3i times 2 minus 3i times 2 minus 3i, which would be very excessive. So in order to do this to the power, you're going to use what's called de Moivre's theorem. And basically, if you have some complex number in trig form already, and n is my positive integer, so I'm taking it to a positive integer, then this would be what that looks like, right? So some complex number taken to n. I say n is positive because if it was negative, remember, it would just be 1 over that, which would be fine. Everything would be come in the denominator. I want to focus just on with the positive ones. We won't deal with negative ones right now. Integer, because we don't want to deal with doing roots. So this is just focusing on regular positive integers like squaring or cubing or to the fifth. So you are going to take the r to that power, just like when we multiplied our r's. When we divided our r's. So we are going to take our r to that power. And then how I had said earlier that with the angles you almost do like 1 less than that. So I would think 1 less than an exponent would be multiplication. So I'm going to be multiplying my angle by whatever n is. Let's do an example together. So here is my complex number, 2 times cosine of 2 pi over 3 plus I sine of 2 pi over 3, and I want you to find z to the 12th. So the first thing you're going to do is 2 to the 12th. And then for my angle, I'm going to do cosine, and I'm actually going to do 12 times 2 pi over 3. Plus I sine, and then again this will be 12 times 2 pi over 3. 2 to the 12th, yes, you're welcome to use your calculator for that part, but it is 4,096. Cosine, if I do 12 times 2 pi over 3, that'd be 8 pi. So plus I sine of 8 pi. Again, this is my answer in trig form. To put it in standard form, I'm going to just do the trig. So cosine of 8 pi, if you want to look at your unit circle, all the way around is 2 pi, and then 4 pi, and then 6 pi, and then 8 pi would still land me right over here. So my cosine there is 1. My sine is 0. So when I multiply that out, I just end up with 4,096. This is my answer in standard form. You will need to know all these formulas for doing your operations.